In this lesson, we're going to look at graphing the absolute value function. So instead of using y, I just used f of x here, equals the absolute value of x. So I can make a table over here, and if I plug in -2, the absolute value of -2 is 2. Absolute value of -1 is 1. So -1, 1. At -2, I go up 2. -3, I'm up 3. So it makes a diagonal on the left side, and then on the right side, it's going to be 1, 1, 2, 2, 3, 3. So you're on a diagonal also on the right side. This graph makes a V, and for the parent function, our vertex is 0, 0. That's the place where it changes direction. The domain, it goes left forever and right forever. However, the range, the floor, or the lowest it goes in the y values is 0, and then it goes to infinity on either side, it goes up. So the range is 0 to infinity, and 0 is included because it does reach that vertex. The parent function, again, is on the diagonal, so you can draw your picture here. And you can graph this on the calculator if you wanted to, which I'm going to do right now. So go to y equals, and math, number over to absolute value, and then I'm just going to type in the x and graph it. And there's my picture. If you wanted to pull up the table, you could. If you go to second graph, there's your table. If you want some negative values, you can get those. So you could graph your points there. Let's go ahead and see what happens if I graph the absolute value of x plus 2. So I'm going to type the x here, and notice that plus 2 is on the outside. When my calculator graphs, it's going to graph the first one, and then I want you to watch and see what happens when I graph the second one. I guess I already had the first one graphed. So if you see, the graph moved up 2 spaces. So having that plus 2 moves my graph up 2 spaces. Let's go ahead and graph that on our paper. So from my calculator, everything on the parent function moved up 2. So I'm going to go ahead and graph that in red on my paper. So I've got the plus k, so k is 2 in this case. And that made my graph go up 2 units. Let's go ahead now and change that on our graphing calculator. And I'm going to change that second graph to plus 5. I'm going to graph it and see what happens. Okay, so here's my parent function, and notice my graph just moved up 5 spaces. It didn't change the shape, it just moved every point up from the parent function 5 spaces. And let's go ahead and put that on our graph. And you can pause this video and make your graphs. That's what I'm doing. So for my third graph, I made that in purple so you can see the differences in my graphs. K in this case was 5. So my graph shifted or translated up 5 units. My next graph I'm going to do in blue. And in this case, k equals -3. You can probably guess what the graph is going to do, but let's go ahead and graph it anyway. So I'm going to change this to a -3. Make sure you use the subtraction key and not the negative at the bottom. If you use the negative at the bottom, it's multiplying it by -3, and you'll get a different graph. So this is -3. And I'm going to hit graph. And I'm guessing you had figured out that this was going to shift the graph down 3 units. So here are the pictures of the graph. Let's go ahead and describe what's happening in each of these situations. So if K is positive, the graph shifts or translates up K units. And if K is negative, the graph shifts down K units. For example 2, I'm going to graph my parent function again. It's on the diagonal. And let's go ahead and see what happens when I put my number inside the absolute value. And this is going to be our H values. I'm going to go ahead and put in my H's for each of these. So for this second graph, H is positive 2 as you're subtracting H. So you can think of it as the opposite of what you see here. And then my next graph, I'm going to do in purple. And for this graph, H is positive 4. And my last graph, I'm going to do in blue. And H this time, it's minus H. So you have to think the opposite here. So that's H is negative 5 in this case. Let's graph these on our calculator and see what happens. So for my second graph, I'm going to go ahead and just clear that. We'll go to math, over to number, absolute value, and I have X. Make sure you use a subtraction sign. Do not use the negative key, otherwise it's multiplying it. We're subtracting 2 and your parentheses. And when I graph that, my parent function, notice, shifts right 2 units. So let's go ahead and graph that on our paper. Again, you can pause this while you graph these. H is 2, moved our graph right 2 units. Let's go ahead and try X minus 4 in the absolute values. So go back to Y equals, and all I need to do is change that 2 to a 4. And then when I graph it, there's the parent, and notice it moved to the right 4 units this time. Let's go ahead and graph that one. So I just graphed it in purple. And so H equals 4 moved the graph right 4 units. And then I'm guessing you can figure out what's going to happen when we plug in H is negative 5. So go back to Y equals, and we're going to change that minus 4 now to a plus 5. It's plus 5. I deleted my X. Give me a sec. So X plus 5. Okay, graphing that. This time it moved left 5, so let's put that on our paper. So our graph moves left 5 units. Describing what adding or subtracting inside the absolute values, what happens? If h is positive, so that's like example 2 and 3. That moves the graph right h units. So graph shifts or translates right h units. If h is negative, and that was like example 4, the graph shifts left h units. On the next page of the notes, what happens if I multiply my absolute value by a number? And I'm going to start with a positive number on this example. The parent function is still on the diagonal. Go back to y equals. Let's clear out that second graph. And I'm going to type 2 and then math number to get my absolute value of x. And graph it. There's my parent. And notice that 2 in front made my graph become thinner. It's a vertical stretch. So your graph got narrow in this case. Let's go ahead and graph that. You could pull up a table if you wanted to. On this one, I'm going to do the graph in red. So 0, 0, the vertex stayed the same. But at 1, I'm at 2. At 2, I'm at 4. 3, I was at 6. And 4, I am at 8. Oops, I didn't give 6, or I got too far. And then at 5, I'm at 10. On the other side, at -1, I'm at 2. -2, I'm at 4. -3 is at 6. -4 is at 8. And -5 is at 10. So it's stretched vertically. So in this case, my A equals 2. And it's a vertical stretch. For my second graph, and do that one in purple, my A equals 5 this time. Let's go ahead and change that on our calculator. And that's even skinnier. If I go to a table on this, I'm looking at my y2, that's my second graph. My first one is the parent function. So this is my x's, and this is my y for the equation I just did. Notice that -2, I'm at 10. -1, I'm at 5. 0, I'm at 0. So there aren't a whole lot of points to graph on this. -2, you're up at 10. -1, you're at 5. 0, 0, 1, 5, and 2, 10. This graph is pretty skinny. It's a vertical stretch again. My last graph I'm going to do in blue. This time, A is 1/2. So I'm going to go back here. I'm just going to clear this graph out. And you can either do 1/2 as a fraction, so 1 divided by 2. Or you could also do 0.5 if you wanted to. Going to go to math, over to number, absolute value, x, and let's graph that. My parent function, it graphed first, and the other one, it got wider. This is called a vertical shrink. You're pushing it vertically down. Let's go ahead and graph that one. You can pull up a table if you want to and get points. But on this one, at 2, you're at 1. At 4, you're at 2. And so on. So you can graph this one. You can grab those points from your calculator if you want to. The slope on this side is going up 1, right 2, up 1, right 2, which we're going to get to in a second. That A value is the slope of the right side. And it's going to be vertically half as tall as the original. So all the points on the parent function, the y values, you're dividing by 2. So it's half as high. And there's the other side. So this is a vertical shrink on this one. So if my A value, I'm going to take the absolute value of that. If it's greater than 1, it's a vertical stretch. If your A value, when you take the absolute value, is smaller than 1, so 1/2 is smaller than 1, it's going to be a vertical shrink. A is the slope of the right side. And the opposite of A is the slope of the left side. Let's look at what happens when we put a negative now in front. I'm going to go ahead and graph the parent function on the diagonal. And let's put a negative now there. Oops. So I need to put the negative. I'm going to put negative. And we're using the negative key down here now. If you want to put a 1 there, you can. I'm just going to put the negative. Go to math, over to number, absolute value, x. There's my parent. And then my new one, it's the same shape. It just reflected over the x-axis. So it's now upside down. Let's go ahead and graph that one. So A in this case was -1. And it reflects over the x-axis. Let's graph my next one. I'm going to clear this out. This time I'm going to use -3. Make sure you're using the negative key, not the subtraction key. Then math, over to number, absolute value x, and graph it. Okay, this changed shape, and it also reflected over the x-axis. And it is a vertical stretch. So that's when I said up above that you need to take the absolute value of a. So the absolute value of -3 is 3, which is bigger than 1. So this is a vertical stretch, and it reflected over the x-axis. And you could pull up points on your calculator if you wanted to. If you go to second table, remember we're looking at the y values in the second column, and you could go ahead and plot these. Let me go up for one more. And so at -3 or at -9, if you go to -4, you're off your graph. So I would just start at -3, -9, and let's go ahead and graph these. So -3, I'm at -9. At -2, I was at -6. At -1, I'm at -3. So it's taking that parent function and it's stretching it by a factor of 3. And then on the other side, you'll be at 1, 3, 2, 6, and 3, -9. So here is that graph. Notice the slope on the right side is your a value. So the slope is -3. It's going down 3, right 1, down 3, right 1, down 3, right 1. And on the other side, my slope is the opposite of a. Remember, a was -3. So the opposite of that is +3. So the slope of the left side is going up 3, right 1, up 3, right 1, up 3, right 1. So a is -3 as a vertical stretch. So notice the sign has nothing to do with it, whether it's a stretch or a shrink. The sign tells you that it opens down. It reflects over the x-axis. And on the last one, I'm going to do that one in blue. A for this is -1/2. It also is going to reflect over x-axis. And this one is going to be a vertical shrink. Graphing that on the calculator. So I have -0.5. Math, number, get your absolute value, x. And then go ahead and graph it. And notice it's wider than the original function, the parent function. Graphing this, you can start at your vertex. The slope of the right side is -1/2, so it's going down 1, right 2. Down 1, right 2, down 1, right 2, down 1, right 2. So you can graph those points. And on the other side, it's going down and left. So if you go down and left, that's a negative divided by negative, which is positive. So the slope is 1/2 on this side. Okay, so everything that happened before with a is still true. We're going to also add, if a is negative, the graph is reflected over the x-axis. So if you want to think, it opens down. Now, hopefully at this point, you've learned all the characteristics of the transformations on the parent function. So we don't need a calculator anymore to graph these on. That you can look at the graph, and you should be able to graph it without the calculator, as well as tell me what everything does. Okay, so for this one, K, so A, and I think I'll even write A, H, and K. So on this one, A is 1, H is 0, K is 6. So I didn't multiply by anything, so A is 0. There was nothing here with X, so H is 0, K is 6. So this means my graph shifts up 6. On this one, A is 1, H is 0, K is -4. So for this one, my graph shifts down 4. Next example, A is 1, H, remember you have to do an opposite for H. So H is +3. There's nothing on the outside, so K is 0. And so this one is going to go, it's going to shift right 3. Example 5, A is 1. H, remember you have to do an opposite for H, so it's -2. It's X minus H, so I'd have to write X minus -2. So that would be my H value. And K is 0. So this one is going to shift left 2. On example 6, A is 2/3. H is 0, K is 0. So the 2/3 means it's going to be a vertical shrink because it's the absolute value of 2/3 is 2/3, which is smaller than 1. So this is a vertical shrink. The negative here means it's going to reflect over the x-axis, so opens down or reflects over x. Reflects over the x-axis is the same thing as opens down. I'll take either one of those. And then the absolute value of -6 is 6, and that is greater than 1. So that means it's going to be a vertical stretch. On the next one, A is 1, H, you have to do an opposite for H, so H is 1, and K is this actual value, so K is 2. So for this graph, we're going to go and shift right 1, and we're going to shift up 2. On number 9, I have a 3 for A. H, you have to do an opposite, so it's -2, and K is 0. So for this graph, 3, I'm going to take the absolute value of it, is greater than 1, so this is a vertical stretch. And since H is -2, it's going to shift left 2 units. Number 10. This one does several things. The negative means it's going to reflect over x. It's 0.5. When I take the absolute value of that, 0.5 is smaller than 1, so it's a vertical shrink. Okay, so I didn't write A, H, K. A was -0.5. H was -1, and K is 7. So it's going to go left 1, and it's going to shift up 7. Okay, summarizing everything that we have done. If K is positive, graph shifts up. If K is negative, graph shifts down. If H is positive, graph shifts right. If H is negative, graph shifts left. And then A. If A is negative, graph reflects over x-axis, so it opens down. If A is positive, the graph opens up. So the parent function opens up. If absolute value of A is greater than 1, it's a vertical stretch. If the absolute value of A is less than 1, it's a vertical shrink. And then just note A is slope of right side of the graph, and negative A is the slope of the left side of the graph. And the vertex is the breaking point between the left side and the right side. And this concludes our notes for the day.